So in exercise number 3, we have IJKL has the diagonals that are bisecting each other. So now in this case, how can we show that quadrilateral IJKL is a parallelogram? Now in fact, our plan will be something like this. Since these two diagonals bisecting each other, that means diagonal IK will be bisected, hence creating two equal parts, so as LJ. Now, since there's no point in the middle, why don't we call them as M? Now, then we get to realize that these two uh, pairs of the line segments has been divided into two congruent parts. Next thing which we get to realize is, how about these two vertical angles? Since those are straight lines, vertical angles also must be equal to each other, which allows us to have the upper triangle and lower triangle to be congruent by side angle side, side angle side. Then that tells us that this angle here must be congruent to this angle by corresponding parts in congruent triangles being congruent to each other. But once again, since these are the alternate interior angles, that will tell us that these two pairs of these two line segments must be parallel. So as same manner, we can say that these two triangles must be also congruent to each other by having, this time I'm just going to use this one, that angle being equal to this angle. Since these two triangles are congruent to each other, next thing which we can say is then this angle IJM must be also congruent to KJM. The same way as before, these are also alternate interior angles, which makes these two line segments being parallel to each other. Hence, through the definition of a parallelogram, we get to realize that the given quadrilateral must be a parallelogram. So let us try to write this one up together. So here we have now first, since quadrilaterals bisecting diagonals are bisecting each other, we'll say IM is congruent to MK, and also MJ must be congruent to ML. We can say it's given, or if you want to write down given as the diagonals bisecting each other, then you can simply write this one up as in bisected diagonals have congruent parts, or bisectors divides a line segment into two congruent parts. You can also write it in that way also. Now let's just try to write up second step. Now, then we get to realize that angle IMJ is congruent to angle LMK. Now, so as angle IML must be congruent to angle JMK. Why? Vertical angles are congruent. Step number 3. Then in this case, we get to realize that triangle IMJ must be congruent to triangle KML by SAS, but so as triangle IML being congruent to triangle KMJ. Same reasoning as before. That tells us the angle JIM must be congruent to angle LKM The same reasoning goes for angle ILM being congruent to angle KJM by CPCTC. Now, then we can say the line segment IJ must be parallel to line segment KL, and same reasoning goes for IL being parallel to KJ. The reasoning being when alternate interior angles are congruent, the line must be parallel. Now, since we have two pairs of line segments that are parallel in a quadrilateral, so we can say finally IJKL is a parallelogram. And will be definition of a parallelogram. All right,